Hello student, now we will discuss the new chapter metal and non-metal, in which we discuss first the first subtopic is reactivity series. That is most important. Reactivity series. What is reactivity series? If I write the actual series without writing the definition, so you have to understand this thing, not to learn by heart, but understand this thing, not to learn by rote memorization the particular definition in a very diplomatic manner. You have to understand the focused concept of this topic. That is, main elements are in such a way. The elements are written on here: potassium, sodium, calcium, manganese, aluminum, zinc, iron, lead, but hydrogen is indicated. These are arranged in decreasing order. That is the decreasing reactivity. From bottom to top, that is the decreasing reactivity order. These are not based on the group order like that. These are the separate elements order. You have to remember. Potassium, sodium, calcium, manganese, aluminium, zinc, iron, lead, hydrogen, copper, mercury, silver, gold, platinum, nickel. So that is also this elements, there was not sufficient space, so that's why the remaining downward elements I have written on here. So here is reactivity is also decreasing. Reactivity decreases. And if I am going from top to bottom, from here I have just start and continue, and that is the increasing reactivity order. That is the increasing reactivity order. That is the main series I have written. So what are the things you have to remember in your mind? That the salt which react, any salt which react with higher reactive element in comparison to the given element. It means if the element which is reacted to the salt is higher in reactivity as compared to the element in the salt, it means the reaction will occur. And if it isn't down, it is less reactive, then reaction will not occur. For example, if I wrote an example like this, that zinc plus sulfuric acid, that is ZnSO4 plus H2. One example, zinc, if I react zinc with dilute H2SO4, then zinc sulfate and hydrogen gas release. It means zinc is more reactive than hydrogen. Here the element in the sulfuric acid is hydrogen for the comparison, which is indicated in the reactivity series. Hydrogen is that part which separate the level of the element. It means more reactive, less reactive. Below the hydrogen, less reactive element sometimes. So zinc react with sulfuric acid to give zinc sulfate and hydrogen gas. It means zinc is more reactive than hydrogen, more reactive than hydrogen. That's why zinc will react with sulfuric acid to give zinc sulfate. If it will not react, if it will be less reactive, then it will not react it. The reaction will stop. If I take another example, and if I take more reactive than hydrogen, and if I take another example, copper, iron is react with copper sulfate. Iron react with copper sulfate. It means it has blue color. Blue color. So if we put some iron nails into the blue aqueous solution of copper sulfate, its solution will be aqueous, AU, means water soluble in this salt. So we just get iron is more reactive than copper, so it will displace copper from its salt. It is more reactive element, displace that element from its salt. So the reaction product we will get FeSO4, which turns into green color. It means copper sulfate solution turns into green color. It means iron sulfate is formed. FeSO4 and Cu will remain separately. So this is the thing which I have discussed. The more reactive element will displace the less reactive elements. Any example you can take and react with it, any salts. If it is less reactive, it will not react and not give any product, and it will reactive, then it will give any product. Some of the reaction will take some specific condition. Instead of having very downward group and one is very high, that cannot be possible according to reactivity series, but some specific condition it happened, but it is another factor. Here we will study only the reactivity series, and we have to remember the most reactive element will displace less reactive element from its salt. That's it. So these two examples I have discussed, most important two examples, and you can make practice by taking so many examples on the basis of reactivity series.